There is an object in the universe so powerful that if one were placed halfway between Earth and the Moon, its magnetic field would strip the iron from your blood before you had time to register that anything was wrong. This object is called a magnetar, and it is, without question, the most dangerous thing in the known universe. A magnetar is a special kind of neutron star. It forms under the same catastrophic conditions a massive star collapses. The core is crushed into a ball of neutrons, but something different happens during the collapse. The neutron star spins up so fast, and the convective currents within it churn so violently, that the result is a magnetic field of almost incomprehensible strength. On Earth, a hospital MRI machine generates a magnetic field of about 3 Tesla. The strongest electromagnets ever built by humans reach around 45 Tesla. A typical neutron star has a magnetic field of around 10 to the power of 8 Tesla 100 million Tesla. A magnetar has a magnetic field of 10 to the power of 11 Tesla. That is 100 billion Tesla. It is the strongest magnetic field that physics allows to exist. In December of 2004, a magnetar located 50,000 light-years away on the other side of our galaxy released a burst of energy that lasted just 0.2 of a second. In that fraction of a second, it released more energy than our sun will produce in the next 200,000 years. The burst was so powerful that it partially ionized Earth's upper atmosphere, despite being 50,000 light-years away. Had the magnetar been 10 light-years from Earth instead of 50,000, it would have stripped away our ozone layer and bathed the surface in lethal radiation. Every living thing would have died. The magnetar responsible was called SGR 18620. It is one of roughly 30 magnetars known to exist in our galaxy. They are rare because their extreme spin causes them to radiate away their energy quickly. A magnetar is young, fierce, and deadly, but it burns out within 10,000 years, fading to a quiet neutron star as its magnetic field decays. But while a magnetar lives, nothing in the universe compares to it. The surface of a magnetar is under tension from its own magnetic field, the crust, that rigid crystalline lattice of neutrons and nuclei, can crack. When it does, the result is a starquake. The crust shifts by less than a centimeter, just 1 centimeter of movement. And the energy released in that shift equals the energy the sun will produce in 10,000 years. These starquakes create what astronomers call soft gamma repeaters, flashes of gamma radiation that ripple outward across the galaxy. When astronomers detect one, they know a magnetar somewhere has twitched. The magnetic field of a magnetar is so intense that it affects the very fabric of space around it. In physics, a phenomenon called vacuum birefringence occurs. The magnetic field is strong enough to polarize the quantum vacuum itself. Light traveling near a magnetar takes different amounts of time depending on which direction it is polarized. Space itself becomes anisotropic, different in different directions because of the field. We detected this effect for the first time in 2016 looking at a magnetar called RxJ 1856. 53754. We were seeing the quantum vacuum behave differently around a magnetic object. We were watching physics at its absolute limit. And perhaps the most unsettling thing about magnetars is not their power, but their silence. Most of the time they sit quietly in the darkness between stars, indistinguishable from ordinary neutron stars, waiting. Then without warning they erupt. The universe is full of traps, and magnetars are among the most spectacular. They remind us that the cosmos is not merely beautiful and ancient. It is also violent, random, and indifferent. A galaxy-spanning burst of energy from a star we cannot see, halfway across the Milky Way, can wash over us in an instant. We are not separate from the universe, we are inside it, subject to everything it can do. And it can do this. In 1963, astronomers were puzzled by a strange object in the sky. It looked like a star, just a point of light, but its spectrum made no sense. The light it emitted did not match any known element. It was too bright and too far away to be a star. After months of analysis, they finally understood what they were looking at. It was not a star. It was not a galaxy. It was the brightest thing in the known universe, powered by a monster at its heart. They called it a quasi-stellar object, a quasar, and it would reshape our understanding of the cosmos forever. A quasar is what happens when a supermassive black hole, one weighing billions of solar masses, is actively consuming matter. Gas and dust spiral inward in a vast disk called an accretion disk. As this material falls toward the black hole, it is compressed and heated to temperatures exceeding 10 billion degrees. It glows, not faintly, not modestly, It blazes with the combined light of an entire galaxy, concentrated into a region smaller than our solar system. The most luminous quasars ever discovered shine with the brightness of 40 trillion suns. 40 trillion. Our entire Milky Way galaxy, with its 400 billion stars, produces the light of roughly 20 billion suns. A single quasar can outshine 500 entire galaxies, and the light we see from distant quasars has traveled for billions of years to reach us. When we look at a quasar 13 billion light-years away, we are not seeing the universe as it is today. We are seeing it as it was just 700 million years after the Big Bang. We are looking at the first chapter of cosmic history. The early universe was a turbulent, crowded place. Gas clouds collapsed quickly. Black holes formed and grew rapidly. Quasars blazed across the young cosmos in their billions. Then, as the universe expanded and the available gas was consumed, the quasars began to quiet down. The feeding frenzy ended. The black holes at the centers of galaxies grew quieter, and what was once a luminous quasar became simply a galaxy. The Milky Way was once a quasar. Billions of years ago, Sagittarius, a star, the supermassive black hole at our galaxy's center, was actively feeding. It blazed with quasar-level luminosity. The galaxy we call home was once one of the most extreme objects in the universe. Today, Sagittarius, a star, is almost completely dormant. It occasionally flares as small wisps of gas fall into it, but nothing close to its ancient glory. The Milky Way has grown up, matured, quieted. The nearest active quasar to Earth is called 3C273. It sits about 2.5 billion light-years away. Despite that almost unimaginable distance, it is visible through a small amateur telescope, making it the most distant object any backyard astronomer can see with their own equipment. When that light left its source, the Earth did not yet exist. But quasars are not merely extreme and ancient. They shape the universe we live in. As they consumed matter and blazed with light, they also blasted enormous jets of plasma from their poles, jets that stretched for millions of light-years, heating the gas between galaxies, regulating how quickly new stars could form. Quasars acted as cosmic thermostats, keeping the universe's star formation from happening too fast, too soon. Without quasars, galaxies might have burned through all their gas in a fraction of the time, forming stars in a brief frenzy and leaving nothing for later. Without quasars, there might not have been enough time or enough raw material for a star like our Sun to form, in a galaxy calm enough for a rocky planet to develop life. The brightest things in the universe helped create the conditions for the quietest life, a person sitting on a pale blue dot, in a galaxy that was once itself blazing, looking out at the sky and wondering, what if? We are the inheritors of a universe that burned itself bright so we could exist in the glow. Every map has an edge, and the universe has one too. But the edge of the universe is unlike any border you have ever imagined. It is not a wall. It is not a void. It is a horizon, a point beyond which light has never had time to reach us. And what lies beyond that horizon is one of the deepest, most humbling mysteries in all of science. We live in a universe that is approximately 13.8 billion years old. Light travels at roughly 300,000 kilometers per second, the fastest that anything in the universe can move. So the farthest we can ever see is the distance light could have traveled since the Big Bang. That sounds like it should be 13.8 billion light-years. But the universe has been expanding the entire time, and so the observable universe is actually about 93 billion light-years across with us at the center of a sphere of space we can, in principle, observe. But here is the question that should keep you awake at night. What is beyond that sphere? We do not know, we cannot know, not directly. But the mathematics of cosmology, combined with our best observations, gives us strong hints. And what those hints suggest is both thrilling and vertiginous. The universe beyond our cosmic horizon is almost certainly more of the same, more galaxies, more stars, more planets, more black holes. The same physical laws, the same fundamental constants. But it goes on, far beyond what we can ever see. In some models, it goes on for an almost unimaginable distance before the density of the universe shifts, and regions with slightly different arrangements of matter begin to dominate. In others, the universe is truly infinite, no edge, no boundary. Just space extending forever in every direction, filled with more galaxies than there are grains of sand on every beach on Earth. And then more beyond that, and more beyond that, without end. If the universe is infinite, then every possible arrangement of matter occurs somewhere, including a region of space that is statistically identical to ours, including a solar system like ours, including an Earth like ours, including a version of you sitting somewhere unimaginably far away, reading, or listening to these very words. In an infinite universe, everything that can happen does happen infinitely many times. This is not science fiction, it is a straightforward consequence of infinite space and finite patterns of matter. The idea is called the level 1 multiverse, and physicists take it seriously. But even if the universe is not infinite, even if it has a finite volume, it may still have a topology we cannot see from inside. The universe might wrap around itself like the surface of a sphere, so that if you traveled far enough in one direction, you would eventually return to where you started. We might be living inside a cosmic bubble, bounded not by a wall but by curvature. One we launched spacecraft in the direction of the edge. Voyager 1, launched in 1977, is now over 23 billion kilometers from Earth, the farthest any human-made object has ever traveled. 2, it crossed the heliopause in 2012, entering interstellar space. And yet, it has barely left the front porch. At its current speed, it would take 70,000 years to reach the nearest star. The edge of the observable universe is 2 million times farther still. 3, the universe is not merely large, it is large in a way that defies the capacity of the human mind to truly comprehend. And yet we build telescopes, we calculate, we theorize. We send small metal probes into the dark and listen to them fading. We point our greatest instruments at a patch of sky that looks empty and find 10,000 galaxies hiding in the dark. We are a species that has existed for a fraction of a cosmic eye blink. We live on a speck of rock orbiting one star among hundreds of billions in one galaxy among trillions. And we have looked outward and asked, how big is this? What is beyond the edge? What came before the beginning? That impulse, that refusal to accept the boundary, is the most extraordinary thing in the known universe. Not black holes, not quasars, not magnetars. Us reaching for the edge of